Imagine spending hours, even days, manually setting up servers, configuring networks, and ensuring systems are connected. Now picture doing this every time your project scales or changes. It's a process that's not only inefficient, but prone to errors. This is where infrastructure as code, or IAC, revolutionizes the game. IAC allows you to manage and provision your cloud infrastructure using code, automating the setup with precision and consistency. By adopting this approach, you eliminate repetitive manual tasks, reduce the risk of human error, and unlock the full potential of your infrastructure. In this video, we'll explore why IAC matters, how it works, and the tools you need to get started. Ready to leave the inefficiencies of manual setup behind and embrace the future of infrastructure management? Let's dive in. Imagine managing your infrastructure the same way you manage your software. That's the essence of infrastructure as code, or IAC. Instead of manual setups, IAC treats infrastructure as software. It's version-controlled, tested, and repeatable. Just like you wouldn't deploy an application without ensuring its code is solid, IAC ensures your infrastructure is built with precision and consistency. This approach eliminates the risk of configuration drift, where manual adjustments lead to inconsistencies over time. It also minimizes human error, paving the way for a more reliable and scalable environment. Embracing IAC means you're not just reacting to challenges, you're proactively building a stronger foundation for your projects. Whether deploying a small application or managing complex systems, treating your infrastructure as software is the key to staying ahead. Ready to dive deeper? Let's explore how this transformative concept works in practice. In the world of infrastructure as code, tools play a pivotal role in streamlining and automating infrastructure management. Let's dive into some of the core tools shaping IAC in 2025. Terraform stands out as a cloud-agnostic infrastructure builder, allowing you to define and provision data center infrastructure using a high-level configuration language. For configuration management, Ansible excels at handling tasks like server setups and application deployments, offering a straightforward approach to managing system configurations. Pulumi, on the other hand, empowers developers to write infrastructure code using familiar programming languages like Python and TypeScript, blending seamlessly with existing development workflows. Beyond these, tools like AWS CloudFormation and Azure's Bicep provide native IAC solutions tailored for their respective ecosystems. Each of these tools offers unique capabilities, from broad cloud compatibility to tight integration with specific platforms, catering to diverse project needs. As we explore further, we'll see how these tools can be leveraged in practical workflows, transforming the way infrastructure is managed across organizations. Let's break down how infrastructure as code actually works. The process starts with writing configuration files. These files describe your desired infrastructure setup using tools like Terraform, Ansible, or Pulumi. Once your configurations are ready, you push them to GitHub. This triggers your continuous integration pipeline, which validates and tests the code. Finally, the pipeline provisions your live infrastructure automatically. Think of it as a streamlined process, from defining your resources to deploying them in one seamless workflow. With a single command, you could spin up virtual machines, databases, and storage buckets across various cloud providers. This is the power of IAC, turning complex, manual tasks into automated, efficient operations. Next, we'll see this in action with real-world examples, showing how these tools can transform your workflow. Now, let's dive into the practical side of infrastructure as code and see how it works in action. In this segment, we'll explore three key tools: Terraform, Ansible, and Pulumi, and demonstrate their capabilities through real examples. First up, Terraform. We'll initiate a Terraform project, create a plan to outline our desired infrastructure, and then apply it to deploy resources. This showcases its power in managing cloud-agnostic infrastructure. Next, Ansible. Using a playbook file written in YAML, we'll configure a server by applying SSH access settings and setting up a firewall. This highlights Ansible's strength in configuration management and server provisioning. Finally, Pulumi. We'll deploy containerized applications using real programming languages such as Python or TypeScript, demonstrating how Pulumi integrates coding flexibility with infrastructure provisioning. These demonstrations will illustrate the efficiency and repeatability that IAC brings to infrastructure management, making complex setups manageable and scalable. Stick around as we transition to understanding why developers should care about IAC and how it integrates seamlessly into modern CI/CD workflows. Infrastructure as code is no longer just a concept for operations teams. It's a critical tool for developers too. Why? Because modern development workflows now require seamless integration of infrastructure into delivery pipelines. With IAC, provisioning and managing infrastructure becomes as predictable and testable as your application code. This approach promotes collaboration between developers, SREs, and operations teams, breaking down silos and ensuring everyone works towards the same goals. And let's not forget scalability. IAC supports CI/CD pipelines, making deployments faster and more reliable. By adopting IAC, developers can achieve a level of consistency and efficiency that was previously unattainable. If you're a developer looking to streamline your workflow and improve collaboration, embracing IAC is not just an option, it's a necessity. When it comes to leveraging infrastructure as code, or IAC, in European cloud ecosystems, the options are robust and varied. Providers like OVHcloud, Scaleway, UpCloud, Exoscale, and Hetzner all support Terraform, making it straightforward to manage and automate your infrastructure. Beyond the technical advantages, using these regional providers can help ensure GDPR compliance, a crucial consideration for operations involving European data. This alignment not only meets regulatory requirements, but also optimizes performance by keeping your infrastructure closer to your user base. By integrating IAC with these providers, you achieve a powerful combination of automation, compliance, and regional efficiency. Such strategies underline the adaptability of IAC in addressing diverse operational needs across global regions. Next, we'll dive into best practices that can enhance your IAC implementation. To ensure the success of your infrastructure as code implementation, following best practices is crucial. First, always store your IAC configurations in Git or a similar version control system. This not only secures your code, but also makes collaboration and auditing seamless. Next, use remote state storage for managing the state of your infrastructure. This prevents conflicts and ensures that the most accurate and current state is always accessible to your team. Additionally, modularize your code by breaking it into reusable components. This enhances readability, maintenance, and scalability of your infrastructure. Lastly, make tagging a priority for all your resources. Tags such as environment, owner, and purpose provide clarity and facilitate better organization and cost management. By adhering to these practices, you set a solid foundation for a reliable and efficient IAC workflow. Up next, we'll explore some of the best resources to truly excel in infrastructure as code. Having access to the right learning resources is key. Start with HashiCorp's documentation and the Learn Terraform platform. These are excellent for mastering Terraform basics and advanced capabilities. Dive into Ansible playbooks by example to gain practical insights into configuration management. And don't miss out on Pulumi Academy, where you can learn to use real programming languages for infrastructure deployment. Additionally, explore the awesome IAC repositories on GitHub, a curated collection of scripts, modules, and community-driven insights to enhance your projects. These resources will not only deepen your understanding, but also empower you to implement IAC effectively in real-world scenarios. Up next, we'll wrap up with a discussion on the future of tech stacks and why IAC is becoming indispensable. Infrastructure as code is no longer just an option. It's a necessity for any serious tech stack in 2025. By embracing IAC, you simplify infrastructure management, boost efficiency, and stay ahead in the rapidly evolving tech landscape. As we wrap up, we encourage you to explore this transformative approach and integrate it into your workflows. Let us know which IAC tool you rely on most. Together, let's build a future where infrastructure management is smarter, faster, and more reliable. If you've enjoyed this guide, don't forget to like, subscribe, and share your insights in the comments.